Okay, we are live. Welcome everyone to yet another episode of the Tetrate Tech Talks. My name is Eitan Suez, and I'd like to welcome you to episode number 12. Let me put on the screen the landing page for the Tetrate Tech Talks. It looks something like this. For those of you who have visited some of our past episodes and been with us, you're familiar with the Tech Talks. But for those of you who are new, I'd like to welcome you. These Tech Talks are a weekly live stream where we feature a conversation with a guest to discuss technology. Sometimes we do tech demonstrations and other things. Sometimes we combine them together. Tetrate, of course, is the enterprise service mesh company. And much of our focus is on service meshes, and that includes technologies and products such as Istio, Envoy, Kubernetes, and much more. But we don't shy away from going further afield, and that will be actually part of what this episode will be about. We'll venture a little further afield and talk about the Spring framework and Spring technologies with our guest in just a few minutes, which I will introduce to you. So again, welcome. These Tech Talks are streamed live weekly, usually on Fridays at 9 a.m. Pacific, noon Eastern time. I am based out of Austin, Texas. I'm in the Central Time, and the objective, of course, of these Tech Talks is to learn and to share knowledge around these technologies and to get to know also the people behind them, the diverse members of the community, and in the process, of course, to have a great deal of fun. So my name is Eitan Suez. I work at Tetrate, and I love to talk tech. And if you're with us live, I invite you to say hello in the chat, in the comments, and just kind of wave hi and tell us where you're coming from, where you're joining us from. It would be wonderful. So on our last couple of weeks, just as a recap of some of our past episodes, on June 10th, 2 weeks ago, we had on a fellow Tetrand, Jose Carlos Chavez, and the subject of our conversation was web application firewalls. If you've missed that, you can click on the link and watch the recording. And then last week, we had on Kelsey Hightower and had a conversation on Kubernetes and service meshes, which was also equally fascinating. And on to our episode today, a conversation with Josh Long. I feel that Josh does not really require much of an introduction, but he is waiting in the wings. I'm about to bring him on. Josh Long is a Spring developer advocate. He's a Java champion. He is an author of a number of books. He's a trainer. It's kind of hard to cite anything that Josh has not done. He has very popular blogs, podcasts, and videos, and is the author also of Cloud Native Java and Reactive Spring. I'd like to bring him on right now. And welcome, and thank you for joining us, Josh. It's a pleasure having you on. And yeah, of course. And I suppose the first thing I want to do is give you a chance to properly introduce yourself from your vantage point. What would you like to say to our audience?
Well, thanks. So first of all, really excited to be here with you all today. My name is Josh, as was just well explained. I work on the Spring team. I joined in 2010 as the first Spring developer advocate, and
wow,
they haven't fired me yet. So that's been
it's a good sign.
Yeah, good sign. I don't know. I don't know why, but I'm still here. I do my level-headed best to help people find their way to production, to success with Spring. And this is a big part of that. This conversation about best ways to operationalize applications built in Spring, for which I think obviously service meshes are a great fit.
Yeah, it's definitely a part of that for sure. I guess for the benefit of our audience, I recall in terms of, it's funny, we don't really have much of a history. We don't really know each other. But I feel like in many ways, I know you just from watching so many of your videos and demos and sometimes online. Sometimes online and sometimes live, right, at Spring One conferences. I know you've keynoted some conferences. And what stands out particularly in my mind are these sort of 100-mile-an-hour demos that you do, where in the span of 15 or 30 minutes, you are able to show building a number of applications that sort of work together in concert. And that's always sort of impressed the heck out of me.
Isn't spring amazing?
Yeah, absolutely. And the other thing that sticks out in my mind is just how prolific you are. I don't think I know very many people who maintain such a pace. I know you juggle a variety of things, right? You do obviously the developer advocate role, but you also do the conference circuit as well. That's gotta be quite a strain as well. And then on the side, you're writing books and you're doing these podcasts. Can you elaborate on that a little bit?
Oh, right. Oh, so, well, yeah. I mean, it's a lot easier now because of the, we're slowly emerging from the fog of the pandemic. But in 2019, I traveled 650,000 miles, which is about 1 million kilometers for the rest of the world. And that was on planes. Obviously, I didn't walk or anything like that.
Okay.
But that's in 1 year. And that was, 6 of 7 continents, 50 countries, many more cities. And I did that every year for a decade, it's a little bit less each year before. But my point is, by 2019, right before the pandemic, I had clocked in 650,000 miles. At the same time, I do a podcast every week. It comes out. It's just an interview with somebody in the ecosystem that's smarter than I am. A low bar, granted, a very low bar, but still these conversations are really fun because I get people who I used to meet on the road, random people that I so admire and respect, and I would entice them to join me for a conversation. And I'm like, can I turn on the microphone for this? Do you mind? And then most of the time they're just completely fine with it. So
that's wonderful.
Yeah, and then I do this YouTube series every week called Spring Tips, bit.ly/spring-tips-playlist.
Wow.
And that's a YouTube series every week. And then there's a whole series on GraphQL that just, the last 2 episodes just went out last night. And then every Tuesday there's a new blog on spring.io/blog, which it's just a roundup. I've been doing that every week since January 2011. First January 2011 without fail, haven't missed one. And it's just a roundup of all the latest and greatest in the Spring ecosystem. And that's a pretty telling thing, not because of anything I've done, but because there's always something to talk about. I've never once just sat down to write this thing.
Right.
Rain, shine, sickness or health, whatever. I've never once sat down to write this thing and said, gosh, what can I talk about? There's nothing to talk about this week. There's always
fascinating. Yeah. Wow. Okay.
And then of course, presentations. Like I said, I used to do that travel. So I did all that. And then I try and write a book a year, but it's not successful. But now because of the pandemic, I did.
Yeah, the dynamics have changed for sure. Yeah.
I did several hundred meetings last year. So even at my full bore clip before in 2019, doing 1 million kilometers a year, if I did 100 conferences in person, whatever, 100 meetings in person, that was still just 100. Last year I did several hundred, because of Zoom.
I see. Yeah. You didn't have to spend 10 hours on a plane and go into a hotel, all of that.
Right.
Yeah.
And that's the other thing. I would do a 12-hour flight to China, do an hour-long presentation, and then leave the same day, that kind of stuff. So I did that.
Oh my God.
I'd be China, Russia, London, and then and Brazil in the same week, that kind of thing. And it was just even if I'm doing that kind of a clip, you still can't be in as many places as you can with the magic of technology. So and yet I still somehow got more rest last year. Isn't that weird? Because of
yeah, I guess the travel was maybe a bigger part of it than you thought. Yeah.
Yeah, it takes a lot out of you. So actually, by that metric, I've slowed down considerably. It's been.
Yeah.
This, I don't know. Have you flown this year?
My first trip was for KubeCon EU. Yeah, that was to Spain. That was rather nice, and after a long hiatus. So that was, I think, so far maybe the only trip I want to say. Yeah.
I was in Spain for another conference contemporaneous with that.
That's right. Spring IO, probably, right?
Yeah, exactly, in Barcelona.
That's wonderful. Yeah.
I've only been out of the country 4 times since March of 2020.
Okay.
And all 4 of them were in the last 2 months. It's a very slow
ramp up again.
Yeah. I hope it doesn't go.
Good. Yeah, me too. I'm really hopeful that all of that is behind us now. So I'm really delighted to hear that you still, after all these years, find no lack of exciting technologies to talk about. And so I'm kind of curious, what are the things that excite you today Is there any specific project or technology? And I guess combined with that, another question that I'll sneak in is what are you working on these days? Is it more of that sort of regimen, or are you trying to make a change, or any of that?
Gosh, I mean, this is so again, my when I took this job, I'm not a pure play engineer, right?
Right.
I was contributing a prolific number of bugs to the various Spring projects in 2010 as an open source contributor, and I think they hired me just to get me to stop sending so many bugs, So like, I wasn't fixing them; I was just adding them to the code base. I'm like, please, it will just give you a job to do something else, go to marketing or something. So they hired me, and all kidding aside, like the Spring team was interesting. The makeup of the Spring team, especially back then in the early halcyon days of the early noughties, the Spring team was kind of interesting because most people on the team were, let's say 40% advocate and 60% engineer. Whereas when I joined, they explicitly said, well, for you, the ratio will be the other way around, right? So you'll be 60% advocate and 40% engineer, which is fine by me, right? Because again, I never, on my best day, I'm not up there. I mean, nobody is, right? Like those. Wow. That's why these are the best in the business. So I get to work with them, and I learn from them. And my function has always just been to sort of go from one project to another and see whatever, in whatever capacity I can help make these things better. And so I don't have any one thing I focus on. But I got to tell you, there's been the things that have been really interesting to me. The things I've been finding a lot of time for is GraalVM native image support, right? And GraphQL, right? That's the two latest and greatest sort of things that have been in my mind the last 3 years, 2 years.
Okay. All right. Yeah, I guess that dovetails nicely with I think in general the part of the theme of the next big release for Spring is going to be native support, right? To some extent. Okay.
So Spring Framework 6 due later this year. For those of you who haven't been paying attention, and you'd be forgiven. There's been a pandemic after all, but for those of you who haven't been paying attention, GraalVM is this OpenJDK replacement, and it has a lot of very redeeming qualities, not the least of which is a polyglot runtime that allows you to pull together different languages and run them in the same virtual machine, like Python and JavaScript and R and whatever, all in the same JVM. It's got a hotspot replacement. That's the original, impetus for GraalVM, and that just-in-time compiler is actually, even just by itself, taken by itself, you get like 10% more efficient code, which is free magic, sorcery. Right. But the thing that I think a lot of people talk about these days, the top of mind thing people conjure up when they talk about GraalVM is the native image support, and this process is an ahead of time compiler that takes code, that takes your Java code. It does a reachability analysis on it. So it looks at all the code that's being used directly by code that you're using, and it throws away everything else. And it takes whatever's left, including, and remember, it throws away everything, be it in the JRE or in your class path or whatever. It throws away everything else that isn't directly being used. And it takes whatever remains, and it converts that into operating system and architecture specific native code, right? So like what you would get from a C or C++ program. And the result is amazing, right? These applications, well, first of all, they start up really quickly, 50 milliseconds or something like that for a typical web app. But even more importantly, they take a tiny fraction of their former footprint, right? Because the JRE, Java is a wonderful technology, but in its history, in the long story of Java's evolution, if there's a choice between fast and small, they've always chosen fast, right? And so the result is that, for example, when you run a Java application, when you run code on the JRE, you've got an adaptive native compiler in your production code, right? You're running Java code, handling transactions, and behind the scenes, at any time, your JRE may decide, hey, it's time to convert this into like native code, right? Like kind of like what you would do if you took a C program and compiled it. You've got it's not quite a C compiler, but think about that. You've got the machinery required to do C compilation, kind of native code compilation at runtime. Yeah, just in time. But that means it gets shipped in the RAM of your running process.
Yeah.
The benefit of the JRE is that your bytecode lives here and your JRE is over there. And if you change the JRE tomorrow and the JRE somehow finds some new, and they do this all the time, by the way, it's not a far-fetched idea, but if they find some new way to make your code faster, you can just update your JRE and your same existing code compiled yesterday now or 20 years ago, it just gets faster for free.
It inherits all those benefits. Yeah. And it's completely orthogonal to your code. You don't have to change any of it.
Exactly. Yeah. And that's a magic trick that very few things can claim, but at the expense of having to ship all this stuff. So a Java application is fast. It's insanely fast. And yet it also takes a lot of RAM. With this native image approach, you don't have a JRE. You can't change it tomorrow. But the resulting binary is super lightweight. It doesn't have all this extra memory footprint. You can ship a whole working web application with an embedded database and a web server and all that stuff in like 80 megs, right?
Yeah.
Put that in an Alpine Linux container. You've got a whole thing, 100 megs, whatever.
Nicely packaged. Yeah. It's something that, when you look at other tech stacks, that's I can see why there would be emphasis on doing that, because the footprint of other languages is typically smaller, like a Node.js app or something.
Right.
So let's,
I mean, but imagine the opportunity here. You could use Java and Spring to write operators for Kubernetes, for example, right?
Yeah.
Backplane kind of stuff that you wouldn't want to ship a whole JRE and 500 megs of RAM, whatever. You can do in 50 megs of RAM, no problem.
Right. So new things become possible. It becomes a candidate for other kinds of applications. I see.
Exactly. Imagine Raspberry Pis, that kind of stuff. Where you could do Java before.
Yeah.
Imagine, really, really small form factor devices.
I love it. So I want to switch to another thing that I often think about, which is open source. And I've always been such a fan of the open source model of project management, among other things. And part of it has to do with meritocracy and this idea of a project owner, someone who really cares for their baby, right, so to speak, and just ensures that the project remains vital, healthy, it's with a community around it, and so on. And I've been spending a lot of my time in the last few months thinking about Istio and Envoy. And when I look at Envoy, I see an example of maybe an open source project that's managed that way. Matt Klein is sort of the project owner, or one of the main maintainers of the Envoy proxy, and doing his best to take care of that project and to nourish it and make it grow and so on. And I see kind of the same thing. So I've reflected on the Spring Framework's history, the Spring project, and I kind of want to walk through it with you, not walk you through it, because you know it probably better than I do. But I remember, I guess my age is showing now, I guess it all started with an idea, right? There was a book by Rod Johnson that expressed these ideas, and that sort of dragged a little kernel of a community of contributors around it, right? I think there's a story of how Jürgen Ohler read it over a holiday, over a Christmas holiday, and started contributing to it. And then before you know it, the project jumps from there to needing to provide enterprise support. And so Spring Source, the consultancy, is created, right? Yep. That's one big step in the evolution of the project. And of course, that was almost necessary in order to keep the open source project working. Now, so that's the thing with open source. You have people working on it. There's a limit to how much you can do in your spare time at some point.
And by the way, I just want to underscore with that one thing. They wrote the documentation before they wrote the code.
Wow. Okay. So the ideas basically were put forth first. Is that what you're saying?
Remember, the code came from a book.
Yes. Java without JE or something. Without EJB. JE without EJB. That's what it was called.
Okay. I forget. There's a couple of them. They all kind of, I can see them in my head. I just can't remember the title. But anyway, he wrote the book espousing a better way forward. And as part of the sample code was what would become Spring. People liked it so much that the code itself got turned into an open source project. So that's how much we care about documentation. Before Spring existed, there was a book talking about Spring. You know what I'm saying? Like,
there's a lesson there that should be
switched it around.
That's wonderful. And then I remember, another juncture where I think everybody's first reaction was maybe a surprise. It's like, what is Spring Source is going to be sold to VMware?
2008 was a fun year.
It feels like forever ago, but in hindsight, it was essentially, I think, a set of maintainers who wanted to make sure that this project had maybe the funding and the support necessary in order to keep growing, right? So in hindsight, obviously, it's always makes sense.
Yeah.
And then there was the whole sort of spin-off, right? Pivotal, I think, was born, and it sort of became the new steward of Spring. And now it's back in VMware's hands. And so in what that allowed for Spring to do is to essentially blossom, right? I mean, today you look at Spring, half the time you don't know if you're talking about the Spring framework or the 120 other projects. I don't know how many projects there are that are part of that ecosystem.
Yeah, I mean, when I talk about Spring these days, I'm talking about the ecosystem, right? And actually, that's what you just said is perfectly good point. I used to do the same thing. When it used to be, when you said Spring, there was only one Spring. It was Spring Framework, and then like 2006, you get Spring Batch and Spring Integration, and later Spring Data and Spring. You had CG becoming Spring Security. Suddenly, it becomes very clear to call Spring the Spring Framework. And nowadays, when I talk about Spring, I'm just talking about Spring Boot, and that encompasses everything.
Right. Yeah, that makes perfect sense. You're right. Most of the time, more often than not, it's Spring Boot is sort of the anchor, and then there's everything sort of hanging off of it. And so that thought process brought me back to Conway's law. So for our audience, those who don't know Conway's law, that goes back a great deal of time. I think it was first referenced in Fred Brooks' book, The Mythical Man Month, where it basically posited that the systems that people build, their architecture, is a reflection of the communication structures within the organization that produce those systems. And I'm always marveled by how adaptive the Spring framework has been over time. Because, I mean, I don't know how many frameworks have lasted for maybe 2 decades. I don't remember when framework first came out. Spring first came out. It might have been in early 2000s, 2004, 5. Yeah.
2004 was 1.0, but point of technicality, the first lines of code were written in 2001. So by that metric, we're already 21
years. Yeah, 21 years. Yeah. And that's so that to me is maybe a testament to adaptability and maybe a way of the team to organize itself however is necessary in order to meet the challenge of remaining relevant over the years. I wonder if you have any sort of insight into how do the teams work to actually be able to pull off such a feat?
We listen to our users. It is without whom we would be nowhere, and I mean nowhere. Remember, Spring itself wasn't going to be an open source project, but for the users. You mentioned Jürgen. It wasn't like he joined thinking we're going to create a company around this or whatever. He just wanted to make it work for his use case. He liked it, and he was a user first, right? I mean, the second person in charge, and today still the lead of Spring Framework, 21 odd plus years later. It's all been, I was a user. I started contributing to it, and I loved it, and I sent pull requests.
Right. And, it sort of grew naturally, right? From a need, kind of forged in the fire of production, so to speak, right?
All the bad things, I think about, especially not all, but in the enterprise Java ecosystem, you think about all the things that were developed in an ivory tower in isolation. It doesn't end well. Those things don't connect.
No.
So yeah,
that's so true.
Our users.
Thanks for reminding me that.
We have a distributed team, right? During the pandemic, we didn't skip a beat because we were already the most geographically distributed group within VMware, right? Our team is always the Spring team was built to be, with me being the very glaring exception, obviously, but it was built to be the best, not the local, not the most local. And so we've always worked online, always for the last, as long as
I remember a long time ago going to visit the Spring website, and I think there was a tab on there. I don't know if it's still there, that had a world map with all of these little pins of where everyone is around the globe.
It's a worldwide thing. spring.io/team, and you can see where all these people live. There's no single cluster of us. I think at any one place you may have a couple people at most. I can't.
Right.
Maybe London has more than 2. Probably not. I mean, it's. I live in San Francisco. I live in the Bay Area, Silicon Valley. When I joined, there were 2 people here on the Spring team, right? And then I moved up here, and then there was 3, and then those 2 people left the organization. They retired, and then it was just me. I mean, you would think Silicon Valley, Spring, software, all that kind. No,
that would be
it's
the nexus, but it's not.
a
Yeah,
worldwide thing. Yeah.
completely.
Now there's actually
Yeah, TensorRate is the same way. I agree. We're like all over the world. It's like you don't get much of a break because you could be sleeping at 2:00 in the morning. Somebody's up somewhere.
That's right. And that's a great point. Me, I wake up. My day is routinely 3 a.m. I go to bed at 3 a.m. Wake up, 10. I'm up a little early because of you all, because I wanted to have this conversation.
Appreciate it. Thank you.
But then, I mean, before I used to get on planes, but during the pandemic, of course, I still want to talk to these people. So, you think the Americas from 10 a.m. until, let's say, 4 p.m., 5 p.m. Then you get Asia, Japan, and Korea, and then you get China and Singapore and Malaysia and so on. And then South Asia, you get and by the way, also, this is all happening after 4 o'clock. So 4 o'clock into the evening until like midnight, I can talk to people in Asia, no problem. And then right around midnight, you've got the EMEA, you've got Europe, Middle East, Africa. And so, the Eastern Europeans are like 11 o'clock my time. Then, by 1 o'clock in the morning, you can talk to people in the UK. And then
so the time of day kind of tells you, who you're talking to.
I'm doing presentations all day.
Wow.
It's wonderful, but the community is so big.
Yeah, I agree.
So if you start a conference there.
You got it. So moving on, let's fast forward to today. To me, the one thing that I cannot avoid thinking about is Kubernetes, of course. Right? It came on the scene, as almost like a force of nature, like a big bang, because it keeps expanding, and it keeps drawing in all kinds of projects into it, and it's become a real ecosystem. The thing that comes to my mind is that crazy CNCF landscape diagram. Yeah,
that page is a trip. I don't know if I'm sure people in your audience have listened or have gone to it, but it's a fractal. So if you zoom in, it gets more files, right?
Yes, it is. You're absolutely right. You can keep zooming in forever, right? Just like fractals. That's crazy. So I guess we can't avoid thinking about it, and I think every technology has to think of its relationship vis-a-vis Kubernetes, and so I'm asking myself, how has Kubernetes, or how is Kubernetes influencing the direction or evolution of the Spring tech stack, if at all?
Surely. Of course. Yeah. Can I list a few things?
Yeah, go for it.
Well, first of all, we just talked about native images, right? I think this is a good idea no matter what the context, but in a Kubernetes environment where everything is metered and all that, you want to make that as efficient as possible. So that's a natural thing. We have build packs, right? Build packs.
Yes.
That's built into Spring Boot now. We've had build packs for a while as a separate component, but in Spring Boot 2.4 or 2.3, we introduced native build pack support. So you say maven spring-boot : build -image, and Bob's your uncle. You've got a Docker image that you can then Docker tag and Docker push, and then reference in your deployment or pod. We've got the ability to support config trees, which are basically what you get if you take a config map or a secret and then mount it as a volume in your pod. You get a directory structure where the file names are the keys in the config map, and the contents of those files are the values of the config map. That configuration structure was alien to Spring Boot up until 2 or 3 years ago, right? Now we have built support for that. You can tell Spring Boot, here's a directory structure that's the result of a config map. Read it in as you would anything from a property file or a YAML file.
Yes. Yeah, I remember watching, was there a talk by Craig Walls, I think, who, I think he's involved with that project, but I digress. Go ahead, keep going.
Craig, by the way, is the author of the author of Spring in Action, one of the all-time best books on Spring ever. He's a lovely person, and he's a genius, and I love his books, and I love him. So
I do too. I had the pleasure of getting to know him. We used to long time ago speak on. He's still on that no fluff circuit. I just made a very short stint a long time ago. But it's Craig Walls. I'll put his name and the link to his book in the notes for this episode.
on Twitter.
Habuma, that's right. Yeah.
And what else? Oh, so now Spring Boot also has environment specific configuration. So you can say, I want these configuration values. I want things like again, I don't know how many of your users have used Spring Boot. So we support properties like keys and values, like .ini files, kind of, but we call them property files or YAML files. You can use those properties to override certain runtime components of the or aspects of the application, including things like the port on which the web server binds and whatever. So all that stuff you can plug in via any number of different sources, including the aforementioned config trees. But what if you want some of that configuration to be conditional or to be activated solely at the in the case where you're running inside of a Kubernetes cluster or a Kubernetes environment, right? So you can do that now. You can have activate on cloud platform equals Kubernetes. There's also an annotation, so your Java code can also be dynamically registered based on whether it's running inside of Kubernetes or not. So you can have basic dynamic Kubernetes aware configuration, which kind of goes against the 12-factor manifesto.
Right.
Use it sparingly. It's there if you need it, but obviously the best result is to be able to take the same code from each environment and run it without change. What else? I mean, we have a whole project called Spring for Kubernetes, which gives you the ability to use the API server as a service registry to do client-side resolution and routing. We've got the ability to monitor with Java code a config map to see if anything's changed, and if it's changed, it automatically refreshes configuration in your Java app. So rather than redeploying and restarting the Java process, we've actually got Java code that runs in your Java process that sees the change in the config map. So if somebody does kubectl apply, update the config map, now you've got a new value. The app doesn't need to be restarted. It just sees the new change directly instead of
reloads configuration
or from the config volume.
Yeah.
We've got, it's just an endless list of things, and it just gets better and better. I'm helping. I've got a talk these days where I'm showing people how to write operators using Spring Boot, right? Kubernetes
wow.
Okay. I think it's a really interesting opportunity, right? Now you've got this incredible Java ecosystem, and you've got this imminently programmable control plane. These
you want to play with it, right? You want to interact with it for sure. Yeah, I mean, I know a lot of people go with the Go SDK, but I know that there's a couple of Java SDKs. I think there's a formal one and one that's a little more fleshed out. I forget its name.
Fabricate.
Fabricate. Yeah.
Red Hat did a great job. The official, Red Hat and the official one. Well, the majority of them are both automatically generated. They look at the API server, the definitions, and they.
Nice. So that's how they keep up with the changes. Yeah, which are very obviously.
And they're both very good. So I actually built Spring native hints, so you could do native images out of both. You can take code written against either of those and turn them into native images, and then deploy those. Like I said, at a fraction of the memory footprint and startup time.
Right.
Yeah.
I want to throw out there, there's a talk I remember watching. It's already been, time flies, maybe a year since I've seen it. It's a talk by Dr. Dave Sire on inner loop software development, Spring Boot with Kubernetes, which I thought was terrific because developers basically, I suppose, ask themselves, okay, how do I test my application? If I make a change, how do I keep that loop really tight in terms of seeing the change, without having to restart my application or redeploy it or build a new image and so on. And he sort of walks you through the landscape of all the tools that you can use, like Scaffold and Tilt, and I forget the names of the other ones. But that's an interesting one as well.
The good doctors, and I think he did a blog on that, inner loop development.
Yeah.
I think he did a blog.
And I put a link to it in the reference section to the landing page for this episode. So for those of you who are listening, if you look on our landing page here, let me just pop it up here.
Yeah.
For you guys. Inner loop development. So this is the link. And and that's the video recording. And I'm sure there's also a corresponding blog entry. So this is by Dr. Dave Sire, who in the Spring community needs no introduction, right? It's one of the main lead. Yeah.
He's one of my heroes. I just sent you the GitHub repository for that too. If people want to just look at the code, and it's awesome. If you could bring that up. Dr. Sire is one of my all-time favorite doctors, along with Doctors Who, Seuss, Strange, and Subramaniam.
Yes, with Dr. Venkat. There's a bunch of doctors, right?
Yeah, they're all
Here,
my
let me
favorite.
pull it up for you. Okay. Yeah.
There
So
you
this is the link he sent me. Yeah. And so yeah, he has a corollary, corresponding repository with his code. So if you want to actually work through it rather than just watch it passively, you could do that. That's great. That's terrific. Thank you. All right. So let's carry on and let's move on and talk about Spring Cloud. Now, I in the past life used to be actually a trainer. I used to do a lot of enterprise training for Pivotal, and used to teach. How do you move to cloud native, 12-factor applications, the whole 9 yards. Now, the term Spring Cloud is an umbrella, really, because when you look, and this is another thing that maybe is worth showing to our audience, it's kind of crazy the number of projects. So if we go ahead and open
landscape.
this, yeah, I guess that is exactly a landscape. So if you look at the Spring Cloud project, look at the number of Spring Cloud sub-projects that are under that umbrella. So that's just dizzying, and we can't obviously talk about all of them. It's just amazing what an ecosystem this is. But the ones that I like to focus on are the ones that sort of work in concert with one another, and they are actually represented by a diagram that I found on here. When you go to the cloud landing page, let me open it in a separate tab so we can see. Yeah. All right. Which is a representation of an architecture, microservices architecture you can build out of that involves many of these components, these libraries, right? And that includes now service discovery. And I think the thing that Spring has always done well is that you can swap components, right? If you're using Eureka today, you can swap it for something else tomorrow, for example. So I know a lot of this started with Netflix, which to me is just fascinating to learn the story right behind it, the whole history of how these projects came to be, right? Netflix was moving to microservices. I guess it's an old story now, and they had to sort of build libraries to fill in gaps as they moved to this different architecture. But in this picture, what we see is a bunch of microservices, and these are typically Spring Boot applications.
Yeah.
And we see a service registry, we see a config server that can dynamically configure, it could be a source of configuration for your applications. We see an edge service, which maybe started out as Zool, and maybe today is the Spring Cloud Gateway. We'll talk about that later if we have time permitting. And you've got a box there that talks about the fact that you could do distributed tracing. There's a Spring Cloud projects for that, Spring Cloud Sleuth, right? Yep. And then inside those microservices, those Spring Boot apps, you've got a variety of client libraries, right? You've got something that takes care of doing retries for you, Spring Cloud retry and circuit breaking, client-side load balancing. Ribbon, I think I don't know if it still is the one that's being used, but that comes to mind. You've got
we have something called Spring Cloud Load Balancer now.
Okay, wow. Okay, nice to see that. And the list goes on, right? There's Actuator that gives you like health endpoints for free and other operator things, and then there's Micrometer, which allows you to expose metrics to your monitoring system.
Right.
And I think I mentioned Sleuth. There's the config client. There is, and what's nice is most of the time it's just a dependency. You just sort of throw it in there, and in terms of, it's not really invasive. And in the spirit of the Spring framework in general, that it sort of works. You sort of add it in there, and your app has been instrumented, and now
critically,
it has.
Critically, a lot of client libraries, right?
Yes.
They're talking to something else. And, the micrometer, for example, it's a great example. You have one abstraction, you plug in a different implementation. You can talk to Prometheus today and talk to, Atlas tomorrow and talk to Datadog the day after, right? It doesn't matter. It's the same client code. Same thing for the config client, right? The config client lets you talk to, the code, the way you work with config in Spring is the same, whether you're talking to a config tree or the config server or, anything else, a Vault inside of Azure or something like that, right? Or HashiCorp Vault. It's the same.
Yeah, you can make it work with the specific products that you're using in the context of your projects, right, or your enterprise or what have you.
So your code doesn't change, but the infrastructure to which you talk might change, and that's one of the benefits here. Is this was one thing that makes Spring so natural a fit And why it works so nicely with something like a service mesh is because service meshes can provide a lot of runtime infrastructure.
These components.
that
Okay.
that we can consume within a Spring Boot app.
Yeah, that's something I want to talk about as well. But so if we look at this picture, you can see ingress traffic coming through the API gateway. Microservices can find each other because they've got a copy of the registry, and they can do client-side load balancing to pick an instance of another service. And all these calls are done through REST APIs, but these client libraries don't require you to actually to you it looks like a method call perhaps, and that all sort of gets streamed over the wire. So that's honestly, when I look at this diagram, it looks very similar to a service mesh architecture. And this is where I'm sort of going. What I want to talk about is, I guess the first thing is looking at the proxy first. So that proxy has a story, and I love stories, so indulge me. But it started out, I think, at Netflix, and I remember a talk, and this again is a little bit dated, an oldie but goodie, by Mikey Cohen from Netflix.
Yeah.
And I think the subject was about Zool, and he talks about how Zool sort of was forged in production at Netflix when they had problems and they needed a proxy, and that reminded me a lot of the story that Matt Klein talks about Envoy. So Envoy and Zool are kind of the same thing. We're two different companies moving to microservices, had to invent their solution. Whatever was out there maybe didn't give them everything they needed. I think Mikey Cohen talks about how they looked at Nginx and they looked at maybe HA proxy, and they wanted something more dynamic, something whose configuration they could just reload at runtime. That was really important for them to be able to do that.
Right.
And so they concocted Zool. And one of the things that I thought was really interesting is the way that they were able to achieve their objectives was their Zool filters were written in Groovy, which meant that they could be reloaded without being taken down, which was kind of cool. And now, obviously, that's all history now. I think Netflix released Zool 2, and the Spring framework sort of came up with the Spring Cloud Gateway, which was a way of solving many of the issues with the original implementation. And I want to talk about it. I don't know to what extent you've been involved with that whole saga, but I think it's a wonderful story of a project born out of a need and some of the things it enabled.
Yeah. So Zool, thank you Netflix for that. Obviously they changed the world. They created Zool. It's a servlet filter, right? And it worked well, I suppose, for certain use cases, but the API was a little clumsy. If you wanted to write a custom filter, you literally had a method that was like public object run.
Yeah, very crude, right? Yeah.
And what is object? And it turns out the return value never gets used anywhere. For some reason, it's in the signature. So all the filters you see end up just returning null because we don't know why it's even there anymore. It's been lost.
Okay.
And you have these weird. You have to call a static method to get access to the context instead of just having it given to you in a callback. It's just an ugly API. And Netflix, to their credit, they gave this API to the world. They open sourced as much as they reasonably could, but so much of what made it valuable for them was intrinsically only valuable to them and their particular infrastructure. So many of the common things that people had asked for, things like rate limiting and these kinds of things, it didn't make sense for them to open source it, even if they could, right? Because it wouldn't have worked for everybody. So what we got in just Zool was this very basic engine and few and far between in terms of filters, right? And so then here comes reactive programming. Here comes other new protocols like WebSockets, and suddenly, Zool wasn't able to keep up, and the programming model was becoming tedious, and we were doing a lot of extra heavy lifting to ship all these extra filters that should have been there, or we wish could have been there out of the box. And so it was decided, look, and also the project had become stagnant, right?
Yeah.
They're not. Their job is to help people enjoy media, right? They're not there to build open source for us to just use. Nobody expects that of them, and they've done a great job. Everything they've given us because they're generous and kind. So I appreciate that, but understandably,
yeah, it was time for something to replace it. Yeah.
And since we had already done all that work building those filters, and we'd already worked around the engine so much, and we knew what was required, we knew we had to support these new protocols and new mechanisms. We built something called Spring Cloud Gateway, right? And Spring Cloud Gateway is, I think, just provably better in every scenario.
Yeah.
And with Spring Cloud Gateway, you don't have to write your code in Groovy. We have reloadable config, right? So you can trigger an actuator REST endpoint, HTTP endpoint, and then your routes get reloaded, or the routes can be loaded in from a configuration source, like a property file. You can change that, and then automatically it changes the routes in Gateway.
And I should mention you have a wonderful, I think I want to say a 1 hour plus long recording on Spring Cloud Gateway, where you actually you sort of roll up your sleeves, bring up your IDE, and start coding.
Spring Tips video, Spring Tips on YouTube.
Yeah, which is terrific. That's it. Yeah. So if you want to learn in detail a lot of things about Spring Cloud Gateway, that video I think is probably should be on your list, and I'll make sure to add that link after the episode is over. I'm blanking out for a second. I apologize for that. So there's I want to talk about Gateway some more, but I want to bring it back to Service Mesh. So the thing is, so Mikey Cohen's video, I had watched it years ago, and I happened upon it again recently, but I watched it through a new lens because I'd been spending so much of my time looking at service meshes. And so for the benefit of our audience, which is kind of a service mesh centric audience, this is a canonical diagram of the architecture of service mesh. And there's a lot going on here. It's not my favorite. It's really busy. But you see a lot of the similar elements that you saw in the previous diagram from the Spring Cloud page. Namely that there is an edge service. It's called Ingress on the left-hand side. And then you've got microservices, right? And they're running, it's inside the Kubernetes sort of context most of the time, is the idea that your service, although that's not technically true, you can actually have a service run on a VM with an Envoy sidecar running on that VM, but most of the time it runs inside a pod. And then you've got sort of the brains of the operation, which is Istio, which configures your sidecars. And so I tried to ask myself the important question. It's like, well, what's different in this picture? What's here that's not there? What's there that's not here? And so a few things stand out. One is the decision that Matt Klein did a long time ago at Lyft. And I think that requires a little bit of an explanation of the story of how Envoy was born at Lyft, but similar story to Netflix's really, that they needed a proxy. But the decision they made was to put the proxy out of process, right, which gave birth to that sidecar thing, right? And then the decision then to also put them everywhere, to put them alongside every service, which is interesting, not just at the edge. So every that little purple hexagon is the, I guess, the icon of the brand for Envoy proxy, but you see it both at the edge and inside the mesh. So a lot of the benefits that Mikey talks about, he talks about how they're able to do traffic shaping and how they're able to do chaos engineering by configuring their proxy to sort of look at headers, for example, and make a decision of whether to route that to like a debug backend or some other origin system. I saw this parallel of how it's the same thing, except that here you've got the proxy deployed everywhere. The other thing that's interesting is these proxies are configured through Kubernetes resources. I guess that's part of what Istio does, right? You create some kind of virtual service, and you use labels and selectors, which are a Kubernetes concept, to actually target which proxy you want to configure. So you could say, I want only these types of services, and the services in this namespace are the ones that match a particular service. And then the other thing that stands out is, and this is interesting, it took me a long time to understand, because you play with Istio and it works, but you don't realize that behind the scenes, it actually assigns a cryptographic identity to every service that's running inside your mesh. So every one of these guys has like a certificate, and they get rotated automatically for you. And so you see these lock icons there, which represent a mutual TLS connection that's happening. And so that gives rise to the whole conversation around zero trust architectures. The fact that I think Netflix originally, back in the day, now obviously it's not a fair comparison in that Netflix was much earlier, right, at the time where people were trying to figure out how to do this. But inside their environment, I think they were just running plain HTTP.
Right.
So that's another difference I see there. But I marveled at the intersection, how those diagrams are really not that different from one another. And so my question to you is, I wonder if, and I don't know, it's not necessarily a question for you, but I ponder about the Spring framework and the Spring Cloud projects. Are they influenced by some of the ideas they see in these architectures as maybe a way forward, a way of maybe creating new Spring Cloud libraries or things to adopt? Maybe playing with sidecars is one of these things that sort of has become kind of a mainstream idea of putting something inside a pod alongside your application. Is that something Spring is sort of thinking about going towards, or anything of that?
Well, yes and no. So yes, because I mentioned Spring Cloud Gateway, right? And yes. we have a Kubernetes version of that, which is basically a sidecar. You can use Kubernetes CRDs.
Gotcha. I did not realize that. Okay.
Yeah. It's it gives you a lot of the benefits of Spring Cloud Gateway, and it handles, you can do routing and things like that. So there's that. But on the other hand, a lot of the things that we do, again, going back to what we talked about before, whether you're using Envoy or Spring Cloud Gateway or whatever, your Spring Boot app itself doesn't care, right? So for example, your app, if you're going to do TLS, well, obviously my app doesn't need to care about that. It's going to be ignorant of the connection between the two sidecars. And then once the message comes from the sidecar to my pod, then I'll just get the message. I don't care.
Yeah, how it sort of works its way to you, so to speak.
And then something for tracing. Tracing requires the perpetuation of headers. Again, Spring Cloud Sleuth looks for those headers, but who gives me those headers I don't care.
It's immaterial.
Within the bounds of my Java app, Spring Cloud Sleuth can propagate the headers from one logical boundary to another, and then from ingress to egress. But once it's entered the virtual machine, it's all Spring Cloud Sleuth. Once it's left, it's no longer
the concern of another piece of the system, another component.
So
or
if you're using a sidecar to perpetuate those headers, great. If not, something else will do it. I mean, Google Cloud has built-in support for that kind of stuff. Somebody's got to do that, right? We don't care who.
Right.
When you're doing configuration, again, Spring Cloud doesn't care whether the configuration gets injected via a config tree or a config map, a secret. Doesn't care if it comes from an environment variable. It's all the exact
I see what you're saying is that Spring Boot essentially can work wonderfully inside a mesh. There's nothing preventing it from being. Yeah,
100%. So we like the process. We like the pattern. Obviously it's provably a good idea for a lot of use cases, and because Spring Boot code doesn't need to care, why wouldn't we?
Yeah, they're orthogonal things. Yes, I understand. That's wonderful. All right, so the other thing that I'm really almost delighted to bring this to you, because I love seeing similarities between things, and so I think of the Spring framework, and the two things that stand out to me are dependency injection and cross-cutting concerns.
Right.
And so I went through this. I tried to look for an illustration, and I found one, and it's very, very simple. There's not much to it, right? This is, if you want to explain to someone what dependency injection is, which I kind of like the former term. There's some history there, right? Inversion of control. I think at some point Martin Fowler opined on terminology, and he said, you guys should consider calling it dependency injection. It's maybe a little more apt, but I like both. And the idea there, right, is you've got some client that needs to call a service, and it better than anyone else. And the client needs to have a reference to the service, and the question is, how does it get it? And that used to be a PIDA, right? That was essentially the motivation for creating Spring in the first place, is to create some injector, right, some application context that could configure your clients so that they had references to the service they needed to call, which was wonderful. And that sort of changed the world. And so I asked myself, this pattern looks familiar. As I looked at Istio, I saw it again. Mm-hmm. So Istio is the injector for Envoy. Essentially, it took me a long time to arrive there, but what I realized is Envoy is blissfully unaware of what its configuration ought to be, because its configuration is injected by Istio. And if your Kubernetes topology changes, if new services get added, that gets injected as well. So I'm like, wow, here's something that at a different level of resolution works the same way, and so it must be good, right?
Yeah.
And so I wanted to flash it by you. Yeah. Go ahead.
Oh, I was just gonna say, at least it's good. I don't know if it's good. I think it's good, but it's at least flexible, and optionality is exactly what architecture is all about, right? Is buying yourself flexibility to make change later. A lot of times people bemoan that extra flexibility, decrying it as too many moving parts, whatever. But if you need it, you need it, and this is it's the same principle, yeah.
Yeah. Okay, so the other one which I found really interesting is this notion of AOP and cross-cutting concerns. And that is so important, right? It almost is complementary. Like there's a OOP and there's AOP. When we talk about cross-cutting concerns, we talk about security. We talk about having some kind of gatekeeper in front of some object that's able to maybe short circuit that call if necessary, right? There's a number of different use cases for it. And so I went ahead and I did a Google search for an image. I was looking for some kind of illustration. And I came up with this. This is not so good. This actually, I don't really care so much about the comparison it's making between on the left, I think, using a JDK proxy, whereas on the right, they're doing some kind of instrumentation where bytecode is generated. But what I was almost taken aback by when I first saw this diagram is how similar it looks to this part specifically, how similar it looks to this, which, and it's not a coincidence. It's because on the left-hand side, you've got a bean, right? Some kind of bean and some method, that needs to be called by somebody, by some client on the left-hand side. And you've got to have some kind of aspect in front of it in order to be able to do cross-cutting concerns. And when you sort of break your monolith and that bean becomes a separate microservice, inside the pod, having a sidecar sort of plays the same role. And so as you sort of break your monolith into pieces, you could sort of take your AOP with you. I don't know if that makes any sense. I tried to, I had a conversation about this last week with my guest and tried to get his opinion on that. To me, it was an epiphany. I'm like, wow, I've never seen it before. But it's not a surprise because when you read about Istio, the term cross-cutting concerns keeps coming up over and over again.
Yeah. I mean, HTTP, so the magic trick here is HTTP, right? It was implicitly designed to be layerable. So I can have the endpoint over here that is 5 hops down from the originator of the request, and it doesn't know that. And I can add a 6th hop in between, and it still works, right? HTTP was designed to be layerable. It's designed to be proxyable. And because most of the web is built on HTTP, this works great, right? Obviously, it works great. And so I when you have a proxy, you introduce that ability to enrich the payload, to change it, to do all sorts of interesting things there. And yeah, it makes sense, obviously. That would be magical.
Yeah, for me, it was kind of a fun exercise because, I was trying, I'm in the world of service meshes, and a lot of my past is in Spring. And so I was looking for commonalities between them. And I think it was delightful to see that certain patterns repeat themselves at different levels of scale. It's just an enjoyable exercise. And it helps you gain a deeper understanding in the process too. Yeah.
Oh, yeah. I mean, it's good that we by writing our apps to be ignorant of these extraneous concerns, we've now gotten to a point where it's much easier as in terms of the infrastructure that we built to then support these apps. So that inversion of control mindset, I don't know that we wouldn't have gotten service mesh and all that without the 12-factor manifesto, without the idea that you externalize these things.
Yes.
It's easier to open the door for that, right? One leads to the other. So remember the bad old days of the Java ecosystem. You deploy your Java app with this application server, right? And you would explicitly you'd instantiate all these resources you needed. You'd look them up explicitly, and so your apps were tied to the application server, and then the application server was just sort of this black box that didn't care about its environment. But then we got rid of the app server, and we made it so that the things that the app cared about could come from the environment as opposed to the context in the application server. And then now it's something, there's a barrier between the app and the runtime, the infrastructure, but it's getting more and more permeable, And then you get to things like service mesh and cloud, and it's just, and indeed that's the original use case for Spring Cloud. We talked about that a minute ago. The dizzying landscape. The original use case there was, I want client libraries to talk to infrastructure specific to different
environments.
Right?
Yeah.
And so, a lot of that is what we have today. You have Spring Cloud for AWS, Spring Cloud for Azure, Spring Cloud for Alibaba, or Aliyun as it's called, Spring Cloud, GCP, Spring Cloud for Kubernetes, because we have these common abstractions that let us consume primitives on these different platforms, these different runtimes with the same code,
Yeah. The thought that comes to my mind from listening to you is that old adage, standing on the shoulder of giants, of
So,
how,
yeah,
and you have this perspective of how far we've come from one idea that sort of grew and became adopted, and another idea that influenced it. And none of these could have happened without the predecessor, sort of,
sure.
so to speak.
Maybe they could have. I don't know, but it feels like one followed the other, and that's great. It feels like we've made a large
making progress. Yeah,
exactly. We're moving forward in the right directions technologically, hopefully.
Wow.
It's a good time to be an engineer right now. It's a good time to be building systems because we have so much flexibility, and people, again, if you're building this ecosystem right now and you're looking at the landscape page for the CNCF, or you're looking at the Spring Cloud,
Spring landscape place, yeah.
Landscape page, for better, I do a show called Cloud Native Crew. It's me and my co-host Deshaun Carter and Corey Berkeley.
Nice.
We do the show, and we just did a live edition. We just did a live show in Toronto, right? So we recorded the episode while we did it in front of an audience. And one of the things we did there was just spin the wheel and you pick a landscape component.
Nice.
If we could guess what it did, because there's literally most of the very large majority, all jokes aside, come from the CNCF, right? There's thousands of those and maybe a few hundred of the Spring ecosystem, maybe 100. And, it's fun. It's actually, it's so crazy to think that we've got this so expansive an ecosystem. And by the way, going back, every single one of those players on that landscape page, almost all of them have written an operator of some sort, right?
Yes. Yeah, that's true.
As amazing as Kubernetes is, there are literally thousands of people that woke up one day and said, this doesn't quite do what I want it to do. I need to write some more code, right? But at least it's credit supports that process,
Yeah. Yeah. Well, what a delight it is to talk, being able to talk tech with you and to look at the sort of the intersection between these two worlds, the sort of the Kubernetes center and the Spring. Huh?
The pleasure's been mine. Of course.
Thank you. And to our audience, you've wasted another perfectly good hour listening to us talk tech, but I hope, all jokes aside, that you've enjoyed this conversation, that it was thought-provoking. And I really want to thank you, Josh, for giving us your sort of an update on what you're doing and your point of view on all of these technologies. And I really hope we can continue that conversation in the future.
Likewise, this has been a lot of fun. What a great way to spend a Friday morning, coffee and a friend. Thanks for having me.
My pleasure. And all the best to you.
Cheers.
Bye.